Hello, this is Hui. Welcome to watch my video, C++ Programming on Linux. In this short video, we are going to discuss process resource usage. Most times, we facing system performance issue, and especially for a huge project, very heavy program, very heavy load system going down. So to check, verify performance issue is very important. So one of method to check your performance issue is to get statistics how much resource used for the process. So the function we're going to use is man. So this is the function, the get R usage is the get resource usage. So we're using this function to check how much resource used with our process. To use this function, we have to include header files, time, and the sys resource. So this function needs two parameters. First one is who, second one is the structure usage. So the who has three options. So R usage itself, this option is return the resource usage statistics for the calling process. So we are calling running a process, and we call this function. It will return the usage statistics, resource usage statistics. So if we using the R usage, the children, this return the resource usage statistic for all the children of calling process. So it's if our process is generate a children process. For example, we made a video in previous video using the system called the fork to generate a child process. So we can use this option using this function to get the children process usage statistic. And this is after the Linux kernel 2.6.26, and there's the third option we use is our usage thread. So if your program uses lots of threading, and we can use this option to check how this option returns the resource usage statistic for the calling threading. So it's so you can check how your threading is going, and so after we got our statistic, and we can decide what we can do from the improve our program. So the structure usage has following as long R max usage R x RSS R RU underscore R ID RSS. This means the maximum residence set size, which is the maximum physical memory usage, and the RU time, which is the user computer time used. RUS times is the system used for this process. And also we have a page reclaims, soft page fault, hard page fault. So the soft page fault is sometimes it's not a fault. It's the Unix Linux has memory and the virtual memory. Sometimes if memory is not enough, the data will be saved in the virtual memory. So when we code our memory, which is mapped as virtual memory, so the operating system will be calling move from virtual memory to the physical memory and then to running process. So this number is very important performance here. This number is very high. It means we have to improve our program or system to reduce this number, because continue move forward backward from the virtual memory to physical memory is the huge performance issue. So we have to reduce this number. So this is a swapping. It's also the swapping from the physical memory to the virtual memory, which is, so there's a block into operation, block output operation. It means we have physical in and write out from the file disco writing out, and the message is send out, the message received if we have used the message queue, and signal received. So also voluntary context switch and the involuntary context. These two is a parameter is also very important. It means so when we running program, sometimes we load this data into the cache, and the system process can CPU can running. So because of the Unix system and the Linux is multi-processing, so sometimes if other process is running, you have to move out, switch to the other process. So voluntary means is most usually it's our process waiting for something, so we move out, give to other process to running. So it's a voluntary context switch. Involuntary context switch is sometimes the system is busy, there's other process is running, it's a high priority or very urgent or whatever there, so they kick us out, so they moved in because for some like a high priority or high scheduled. So this number is also involves how busy our system is. So this is the structure, and this is the parameter which we can go into use, and this is a function to use. So okay, so now let's say we have a program called R usage. So in this program, we just have very simple. We just create a structure. It's R usage. Pointer is P usage. It's new instantialize this object R usage, and with pointer, and we call the get R usage, which is R usage itself, which is current calling process, is current process. So the return is this, and the statistical into the P usage, pointer usage. So if returns 0, means a success. So we just print out all our usage structure, the number, so we can get our statistical number. And if it fails, we just fail to call and get usage functions. So let's just save this. So after compiled, we just run. Now we got our statistic. So typically we remove the 0, which is so we got this maximum physical memory use 2864, page fault without I/O, so it is not a disco I/O page fault, and 153 times, and the one voluntary context switch. So it means one voluntary we are waiting for something, so we just making switch. So in this number looks a little higher, and this number is okay. So now let's back to our program. So if we increase something like a threading or disk, read out, so we create a function. So read write file. So we get a file in file name, out file name. So we read the in5 and push into the vector and of 20,000 lines, and then we make a loop of this vector from beginning to the end. We just write into output files, then flash our output file and close the file. So we created this function, and we create other function which use memory. We just allocate a 8K memory, make just set the memory, assign the memory, each memory character with A, and so we try to create a thread calling this function. So we just copy paste. So what we do, we check the argument, and we have neither the input file and the output file, and we create a thread of 10 thread of that function, which is function is called user memory. And so we use the STD filter to instantialize the array of the threader, and we use a STD asyncer to call this function, and use a thread gate to start get our threading for 10 times. And then we open the file and push into the vector and close the file and write to the output file. So, and then we call our get usage to say what's statistic after we add this change. Make part of this program. So we run this program. This time we need the input file, which is the example.txt file, and the output files is called example example out.txt. Now we got our statistic again. So now we have a new statistic of a process, resource usage. So in this case, when we add the threading, and our maximum physical memory used increased almost very high, from the 2864 to 480. So it means our program needs more memory. And there's the page fault from the 153 to 816. So it means our physical memory is, system is too low, so we have to increase our physical memory. So the involuntary context switch and the voluntary context switch is from one voluntary context switch, which we have 17 voluntary context switch and then 19 involuntary context switch. This just means, after we add our program, we add the threading, but we increase the parallel processing, but our page fault increased a lot. It means our performance not improve too much, especially also our memory continue switch from, this is a switch for other process and the first switch by other process. So sometimes these three parameter is very important. Try to reduce this to improve the performance. And because we have a physical file reading and writing, so we have a read from file system, which 1056 times, writing is 1056 to the system, to the disk. Sometimes, for the file system, we have a number of files, open file, and file size. So sometimes in order to reduce the number of this one, to improve the performance, we have to increase the file size. So in most cases, this is just using our usage, get our usage to get our statistical report, so we can understand which part we can improve for our program. Hello, this is Hui. Thanks to watch my video. Hopefully this is useful, enjoyable. It's going to be great to have your feedback.